Welcome to this lesson on kinetic energy, part of our energy series. Kinetic energy is one of the fundamental forms of energy in physics. It's the energy that objects possess simply because they are moving. Whether it's a rolling ball, a flying airplane, or even molecules vibrating in the air, all moving objects carry kinetic energy. Today, we'll explore what kinetic energy is, how to calculate it, and why it matters in the real world. So what exactly is kinetic energy? Kinetic energy is the energy an object possesses due to its motion. Any object that is moving has kinetic energy. The faster it moves, the more kinetic energy it has. We calculate kinetic energy using a specific formula, Ke equals ½ mv². This formula tells us that kinetic energy depends on two factors, the mass of the object and its velocity. Let's break down this formula in detail. Let's examine each component of the kinetic energy formula. Ke equals ½ mv². The letter m represents mass, measured in kilograms. Mass is the amount of matter in an object. The letter v represents velocity, measured in meters per second. Velocity is the speed and direction of the object's motion. The 1/2 is a constant that comes from the derivation of this formula. Understanding these variables is crucial, because they determine how much kinetic energy an object has. Here's something really important about kinetic energy. It depends on velocity squared. This means velocity has a quadratic effect on kinetic energy. What does this mean in practice? If you double the velocity of an object, the kinetic energy doesn't just double. It increases by a factor of 4. For example, a car moving at 20 meters per second has 4 times more kinetic energy than the same car moving at 10 meters per second. Speed has a dramatic impact on kinetic energy, which is why high-speed collisions are so much more dangerous. Unlike velocity, mass has a linear effect on kinetic energy. Kinetic energy is directly proportional to mass. This means if you double the mass of an object while keeping its velocity constant, the kinetic energy doubles as well. The relationship is simple and straightforward. A truck with twice the mass of a car, moving at the same speed, will have exactly twice the kinetic energy. This linear relationship makes mass a predictable factor in calculating kinetic energy. Kinetic energy is measured in joules, abbreviated as J. The joule is the standard unit of energy in physics. 1 joule can be broken down into base units, kilogram times meter squared per second squared. This comes directly from our formula. When we multiply mass in kilograms by velocity squared in meters squared per second squared, and then by 1/2, we get energy in joules. Understanding units helps ensure our calculations are correct and meaningful. Let's work through a concrete example. Suppose we have an object with a mass of 10 kilograms moving at a velocity of 5 meters per second. Using our formula, Ke equals 1/2 times 10 times 5 squared. First, we square the velocity. 5 squared equals 25. Next, we multiply. 1/2 times 10 equals 5. Then 5 times 25 equals 125. Therefore, the kinetic energy is 125 joules. This is the energy stored in the moving object. Now let's demonstrate the dramatic effect of velocity. In scenario A, we have a 10 kilogram object moving at 5 meters per second. Its kinetic energy is 125 joules. In scenario B, we have the same 10 kilogram object, but now it's moving at 10 meters per second. That's double the velocity. The kinetic energy is now 500 joules. Notice that by doubling the velocity, the kinetic energy quadrupled. This demonstrates the v-squared relationship perfectly and shows why velocity is such a critical factor. Kinetic energy appears everywhere in the real world. In vehicle safety, higher speeds mean dramatically more energy in crashes, which is why speed limits exist. In sports, fast-moving balls like baseballs or tennis balls carry significant kinetic energy, which is why they can cause injury. Hydropower plants harness the kinetic energy of moving water to generate electricity. Wind turbines convert the kinetic energy of moving air into electrical power. Understanding kinetic energy helps us design safer vehicles, better sports equipment, and more efficient renewable energy systems. Let's recap the key points about kinetic energy. First, motion creates energy. Any moving object possesses kinetic energy. Second, velocity has a squared effect on energy. Doubling speed quadruples the kinetic energy. Third, mass has a linear effect on energy. Doubling mass doubles the kinetic energy. Remember the formula, Ke equals 1/2mv². This simple equation allows us to calculate the energy of any moving object. Understanding kinetic energy is fundamental to physics and has countless applications in engineering, safety, and renewable energy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.